Good morning. I hope that you're having a wonderful day on this Wednesday. This is a video that I'm making because you guys may not know I'm at a golf tournament today, so I will not be here. So I want to kind of pick up where I had to leave off for third period because we got that stupid fire drill yesterday that kind of took us out of our rhythm and it kept us from being able to get through this. So first and second period, you guys can fast forward just a little bit if you want to, so you don't have to rehear what I had already taught you guys. You can go on down to the part about reflections. So anyhow, do want to remind you guys, in third period, you should be watching this. Remember, if it is happening on the inside, it's going to represent some type of horizontal transformation. If it's happening on the outside, it's going to represent some type of vertical transformation. It's really important as we look at these. We kind of went through all of our adding and subtracting and how that represents a translation, or what I like to call a shift. If it happens on the inside, again, it's horizontal and it's the opposite. If it happens on the outside, it's vertical, and it is what it is. So we talked about that. Now let's go down to the next little section here, and these are called dilations. Now, I'm not sure exactly what I got through with you guys in third period, but when we talk about dilations, remember that's kind of a word that we don't use that much. Instead, we use the word stretch or compress. Okay, stretch or compress is what's really going on here. So, as we kind of move into this, I want you to understand a key. And this key, if you follow it, will actually help you quite a bit. For both this one and this one, I want you to notice it's when your A value is greater than 1. Now, one of the things that's going to help you, if you always remember that when your A value is greater than 1, so that's like if you're multiplied by a 2 or a 3 or whatever that number might be, your graph has to get more narrow. Okay? So both of these would be representative of when your graph will get more narrow. If you understand that, it's going to help you to try to picture what you're doing in these various things. If the value is less than 1, so let's say it's 1/2 or it's 1/3, 3/4, whatever it might be, less than 1, your graph will get wider. Okay? It will get wider. So if you keep that in mind, it's going to help you quite a bit, okay? So here's the point. When it happens on the outside, like these two are, if your value is greater than 1, then it's going to what we call vertical stretch. Vertically stretch. And I want to try to picture this. I try to show you guys in class an example of this, but let's take a quadratic let's take an absolute value function. And a normal absolute value function looks something like this. It's a V. I want you to imagine if I took my hand and I grabbed right here, that's my hand, pretty good drawing, I think. If I grabbed right there and I pulled it down this way, so I vertically stretched it. If I vertically stretched it by pulling it down, what it would do to that V, that absolute value, is it would make it extremely narrow. Can you picture that? That's what it would do if that value that you're multiplying by on the outside was a number greater than 1. It's going to vertically stretch it. Okay? It's going to vertically stretch it. Now, if I am multiplying on the outside by a value that's less than 1, so like a 1/2 or something like that, then it's going to be instead vertically compressed. Vertical compression will happen. So let me again try to draw what I would try to show you guys if I was in class with you. When I have that same V, okay? And again, try to picture that I'm taking this thing and I'm smashing it. Okay, I'm smashing, I'm compressing it. So I put two things that, on top and below it, and I just smash those together. What it would do is it would actually make that V get wider. Okay, it would flatten it out. It would make it wider. So that's why when I multiply by a value outside that's greater than 1, in order to make it more narrow, that's got to vertically be stretched, pulled down. But when I multiply by a value on the outside that's less than 1, like a 1/2, it's going to compress vertically, and therefore it's going to make it wider. So these examples would be if I had some function and I was multiplying by some value, and I'm changing it to a quadratic just for the equation, but I want you to notice, how can I tell that it's on the outside? Well, I can clearly see it's on the outside because there's no parentheses. If there were parentheses, you would be able to distinguish. You can't because there's no parentheses, so I'm multiplying x squared by 3 on the outside. That would get narrow, and therefore I would represent that as having a vertical stretch. Now, the example of a vertical compression would be if I was multiplying on the outside by some fraction that's less than 1, like 1/2 x squared. Okay? Now, let's switch gears, and now we're going to say, well, hey, what if this happens not on the outside, but what if this happens on the inside? What if it happens on the inside? Remember, we said if it's on the inside, it's horizontal. So remember, I told you that if the value of A is greater than 1, your graph has to get more narrow. So when I try to picture the same V, but this time I need it to get more narrow, I want you to think about horizontally, what would I do to it to make it more narrow? Would I stretch it this way and this way? Would I horizontally stretch it? No, because that would make it wider. Instead, I would want to compress it because that's going to make it more narrow. So, with that being said, and I hope that you can see my visuals. If you can't, then I'll explain it to you maybe a little bit better using a visual tomorrow when I get back. But when I multiply by an A value that's greater than 1 on the inside, it actually gets horizontally compressed. So with that being said, there's some real similarities in what happens to a graph that gets vertically stretched and horizontally compressed. It makes it more narrow. And you know that those are happening. Why? Because those A values are greater than 1. Now, you picture that same thing I just showed you. If I'm multiplying by a value that's less than 1, it's got to make it more wide. Well, if I took this and I yanked it that way, and I yanked it this way, so I horizontally stretched it, it takes it and it flattens it out. That is called a horizontal stretch. So a horizontal stretch is what happens when your A value on the inside that you're multiplying by is less than 1. So sure enough, a horizontal stretch does the same thing as a what? A horizontal stretch does the same thing as a vertical compression. They both make it wider. They're both A values that are less than 1. It's all about where it's located. If it's outside and it's greater than 1, then it's a vertical stretch. If it's inside and it's greater than 1, it's a horizontal compression. They both do the same thing. If it's outside and it's less than 1, then it's a vertical compression. If it's outside or inside and it's less than 1, then it's a horizontal stretch. So for example, I might have an equation that looks like this. F of x equals, open parenthesis, 2x, close parenthesis, squared. See how I'm multiplying by 2 on the inside? So here's what your brain would process, I hope. You look at this value and you'd be like, hey, that's multiplying by 2 on the inside. Well, it's got to get narrow, right? It's got to get narrow because it's greater than 1. And then I would say, well, that's horizontal. What move makes it more narrow horizontally. Well, that's a horizontal compression. You smash it together. So I know for sure that this one is a horizontal compression. And then, of course, if that value is smaller than 1, so let's say it's 1/3 times x squared. Look, it's less than 1, so I know it makes it wider. It's happening on the inside. So what horizontal dilation makes it wider? That's a horizontal stretch. Okay? So I hope that makes sense. It is a little bit more of a complicated concept as the adding and subtracting is. It's a little harder, but you should be able to understand it because this is greater than 1. This is greater than 1. They're both making them more narrow. Since this happens on the outside, vertical stretch makes it narrow. Since this happens on the inside, horizontal compression makes it more narrow. These two are both less than 1, so it has to get wider. It's happening on the outside here, so it has to be a vertical compression. It's happening on the inside here, so it has to be a horizontal stretch. So I hope this makes sense. If not, we can talk more about it tomorrow. I can show you the visual. Now we're down to the reflections. So now I'm caught back up to where everyone else was. So I want to remind you guys, still there are 2 locations, inside and outside. When that negative is being multiplied on the outside, then you're going to have what I like to call a vertical reflection. Now we're going to go a little bit different direction as far as how we're going to explain that, because what does a vertical reflection mean? Well, look, if this is my coordinate plane and I have something, let me zoom in here, and I have something drawn here, a vertical reflection goes which direction? Well, it goes this direction. That's a vertical reflection. So that means that this graph would do this. So more specifically, when this occurs, we're going to say that it reflects over the x-axis. Vertical reflections will reflect over the x-axis. So for example, as an equation, you would see simply f of x equals negative x squared. Clearly it's on the outside because there's no parentheses. So therefore, this would be a vertical reflection, or like I said, a reflection over the x-axis. And then sometimes it happens on the inside. Remember, inside is horizontal, and because that's a negative, we know that it's a reflection. So it's a horizontal reflection. Now this one's a little harder to picture. Okay, let me go back. Same coordinate plane. Let me draw my same quadratic. Well, this one, instead of having a vertical reflection, it's going to reflect horizontally this way. So what it ends up doing is it reflects in a way where it actually just kind of turns right over on top of itself. So if that negative occurs on the inside and it's a horizontal reflection, we would say it reflects not over the x-axis, that's vertical. It reflects over the y-axis. Does that make sense? I hope that it does. And this is what it would look like. The equation would just have to include that negative inside. I don't know why I drew that so bad. Inside the parentheses, and then with that x squared, or that squared on the outside. So it clearly is happening inside. That is a horizontal reflection. Okay? So I hope that this makes sense. That one's a pretty easy concept. Honestly, we didn't have a whole lot to finish. And then we were going to go through some of these problems together, okay? We're going to try them out ourselves. So with me not being here today, I'm going to kind of work through these with you. And then as soon as I'm done with that, we're going to get your homework, and then you can work on it. So look at number 1, 2, 3, and 4 here. We're trying to match these with these graphs. So what's happened is it's taken a normal quadratic and it's made these transformations. So right here, look, what is happening? You're multiplying by a 4. Okay, that's a dilation. And because that's a 4, you know it's going to get more narrow. That's it. That's all it's going to happen. It's going to get narrow. Now, it's on the, well, we don't have to describe it, but which one of those clearly did nothing but get more narrow? Well, that's clearly C. C got narrow. Okay, look at 2. What's the only transformation that occurred here? Well, I added one where? Outside. That's a vertical shift. And remember, vertical is what it is. So this thing shifted up 1. Which one shifted up 1? A. Number 3, look at that. That's subtracting 4. Where? Inside. That's horizontal. Remember the rule on horizontal? It's the opposite. So that looks like a negative 4. That means it's a positive 4 horizontal shift. What's a positive 4 horizontal shift going to do? It's going to go right 4, just like B does. And of course, that leaves one more. And look at it. It's negative on the outside. That means it's a vertical reflection. Which one flipped over the x-axis? D did. So C, A, B, D. Okay, I hope that you understand that. We're going to move on through here. Here's example 2. These are all transformations that are happening to an absolute value function. So again, I know you could think these through, but I'm not here. So I want to make sure that you guys understand this. So I hope that here's your reasoning. When I look at this problem, what's happening? I'm adding 5. That's a translation. Where? Inside. That's horizontal. Horizontal shift. Now remember the rule inside? It's the opposite. So if that looks like a positive 5, it's a negative 5 horizontal shift. What is a negative 5 horizontal shift? Shifts left 5. That's your way of thinking. I hope that you can all do this because it's not rocket science. I mean, it's really not. It's something that all of y'all could do. Let's look at B. Okay, clearly, all I've added is this negative. Where? Inside. That's horizontal reflection. Think about it. Picture it. Horizontal reflection means that it reflects over this y-axis. So that's my answer. It reflects over y-axis. If you said horizontal reflection, it's not wrong. It's just, I always describe what that horizontal reflection looks like. It reflects over the y-axis. Okay, look at C. This has got a couple things going on, right? It's subtracting 3 inside. Inside, that's horizontal shift. Horizontal shift. It looks negative, so that means it's actually a positive 3 horizontal shift. That means it shifts which way? Right 3. But it also has this plus 9. Where? Outside. Outside's vertical. What else do we know about vertical shift? It is what it is. So that's a positive 9 vertical shift. That's a shift up 9. Okay, next one. We got a negative here. What does negative do? Well, it's outside. That's a vertical reflection. That means it reflects how? Vertical reflection. What does that mean? Over the x-axis. But that's not all. Okay, here's the harder ones. I'm multiplying by 4/5. Where? Actually, before we say where, 4/5. Does this make it wider or does this make it more narrow? Well, remember, 4/5 is less than 1. It's going to get wider. Now, where are we multiplying? Inside. That's horizontal dilation. Which horizontal move? Is it a horizontal stretch or is it a horizontal compression that makes it wider, it's a horizontal stretch. Okay? Picture it. You're pulling at it from left to right. You're stretching it so it gets wider. So this is definitely a horizontal stretch. Okay? Letter E has 3. So first, let's start with that 6. I'm multiplying by 6. Where? Outside. Okay? So that's a vertical dilation, right? Multiplying by 6. Remember what we said 6 does? It's greater than 1. So it's got to get more narrow. What move vertically makes it more narrow? A vertical stretch where I pull it up and down, or a vertical compression where I smash it? Well, this is clearly a vertical stretch. Keep on moving. You got this -1 inside. Well, that's a horizontal shift. Remember the rule? It's the opposite. So if that looks like a -1, it's actually a +1 horizontal shift. So that means it shifts horizontally right 1. And then lastly, we have this -4. It happens outside, so that's vertical shift, and it is what it is. So a negative vertical shift means it shifts down 4. Okay? And the last one, G. G is a little trickier. You got this 5 being multiplied by x plus 3, but still look, it's inside these absolute value bars. So I'm multiplying by 5 inside. That's horizontal. Okay, hang on. 5 is greater than 1, so it's going to get narrow. What move horizontally makes it narrow? A horizontal compression. I hope that makes sense. Next, I'm adding 3, still where? Inside. So, horizontal shift. It's the opposite, so that means it's a -3 horizontal shift. So it shifts left 3. And then, lastly, we have -9, where? Outside. So that's a vertical shift. And remember, it is what it is. What's a -9 vertical shift? Shifts down 9. And there you have naming translations as we see them. Okay? So hopefully you understand that. If you don't, you can hold on to your questions and be ready to ask me tomorrow. Let's look at example 3, and then I'll give you your worksheet. Well, I won't give it to you, but you can have your worksheet and you'll start working on it. What we're going to do is we're going to make changes to the equation f of x equals x squared. So anything I'm doing to that equation. So A says we're shifting 4 units to the right. So let's think, guys. 4 units to the right means that it's happening where? Horizontal shift. Horizontal shift happens inside. It happens inside. So I'm going to put some parentheses with that squared on the outside. Now remember the rule? On the inside, it's the opposite of what it looks. So 4 to the right in my brain, I think +4. So what will it actually look like inside these parentheses? -4. So x minus 4 squared. Okay, look at this one. It's reflected about the x-axis. Okay, so let me get some of this written. Reflected about the x-axis. Okay, here's the x-axis, guys. What kind of reflection is that? Vertical. That's a vertical reflection. So where does it have to happen? On the outside. It has to happen on the outside. So that negative needs to be outside x squared. So no parentheses. There's no inside. Okay, C, it's vertically stretched by a factor of 2, and it's shifted left 5 units. Okay, so let's start with this vertically stretched by a factor of 2. Where does that have to happen? It has to happen outside. So we're going to put that 2 outside. Okay? Now, what about this? Shifted left 5 units. That's another horizontal shift. Horizontal shift happens inside. So I need an inside now. Now, don't forget, inside it's the opposite. When I think about left 5, I think negative 5. So if I think negative 5, what's the opposite in here? Plus 5. So it's 2 times x plus 5 squared. I hope this is making sense. D, it's horizontally stretched by a factor of 1/2. Guys, where does horizontal stretch has to happen? It has to happen inside. So let's go ahead and put inside that 1/2 of x. And it's also shifted down 4. Where does that happen? Well, it happens outside. It's vertical shift. Down is. So I've got my 1/2 x in parentheses with squared on the outside. Why? Because horizontal stretch has to happen inside. So there has to be parentheses. Now remember the rule with vertical shift. It is what it is. So when I think about down 4, I think negative 4. So sure enough, I put minus 4. Okay? E, vertically compressed by a factor of 1/3. Vertical compression happens on the outside. So I'm going to go ahead and put that 1/3 on the outside. Now I don't know if I need parentheses yet, because I know this needs to happen on the outside. So I don't need parentheses until I know there's something inside those parentheses. Well, what does this say? It shifted 1 to the right. Well, there it is. That's horizontal shift. Horizontal shift has to happen inside. Okay, remember the rule. If it looks like it's a positive or 1 right, I think positive 1. But we know it has to be the opposite. So it's 1/3 on the outside times x minus 1 inside squared. And last one, reflected about the x-axis. Again, here's the x-axis, so reflections here would be on the outside. So I'm going to go ahead and put that negative out there. It's horizontally compressed. Where does that have to happen? Horizontal happens where? Inside. So I put that 5 with that x inside, and that's it. So I close that parenthesis, and I put my square on the outside. So there it is, guys. Whether it's describing transformations that you see or taking described transformation and writing equations, you should be able to do this, okay? So you're going to take time now to go ahead and move into your homework assignment. And your homework assignment, it looks crazy long. It's 9 problems, but it shouldn't really take you very long to do. Y'all have plenty of time because this video is not crazy long. So you should have a good 20 minutes, or maybe a little bit less than 20 minutes. So I hope that you work on this. You're welcome to work with your partners that are sitting close to you. Third period, I need you guys to be chill, be calm, get your work done. Because tomorrow I will be checking this. Now, I know that I'm not here today, and if you have questions, I'll be willing to answer them, but I do expect that you guys can get through this, even though I wasn't here to describe it all. All right? Y'all have a great day.